Apple's American-made AI servers from Texas, a milestone in domestic manufacturing. On October 23, 2025, Apple Inc. announced a significant achievement in its domestic manufacturing initiative. The company began shipping advanced artificial intelligence servers from its new Houston, Texas facility. This development represents a major milestone in Apple's commitment to American manufacturing and marks a strategic response to President Donald Trump's calls for increased domestic production. The early completion of this project, ahead of its original 2026 timeline, demonstrates Apple's accelerated push to strengthen its AI infrastructure while simultaneously revitalizing U.S. manufacturing capabilities. This comprehensive analysis examines the multifaceted dimensions of this historic development, including the technical specifications, economic implications, political significance, and broader impact on the American technology landscape. Executive Summary: Apple's Houston facility commenced production and shipment of AI servers months ahead of schedule, representing a fundamental shift in the company's supply chain strategy. These servers, previously manufactured exclusively overseas, now constitute the backbone of Apple Intelligence and private cloud compute infrastructure. The 250,000 square foot facility forms part of Apple's expanded $600 billion commitment to the United States over the next 4 years. This investment encompasses advanced manufacturing, silicon engineering, research and development, and workforce development initiatives. The early production launch signals not only Apple's technical prowess, but also its strategic alignment with the Trump administration's reshoring agenda, positioning the company favorably amid ongoing trade tensions and tariff pressures. The Houston manufacturing facility, from concept to reality. Facility overview and specifications. The Houston manufacturing facility represents a state-of-the-art, advanced manufacturing complex spanning 250,000 square feet. Located in northwest Harris County, the facility operates as an expansion of a multi-building manufacturing campus managed by Foxconn, Apple's longtime manufacturing partner. The location was strategically selected for several compelling reasons: Houston's robust infrastructure, access to a skilled workforce, proximity to major transportation networks, and the region's growing reputation as an emerging hub for advanced manufacturing and AI infrastructure development. The facility's construction timeline demonstrates remarkable efficiency in execution. Originally announced in February 2025, with a projected opening date of 2026, Apple accelerated the timeline significantly. Production commenced in October 2025, nearly a full year ahead of schedule. This acceleration resulted from intensive coordination between Apple's project teams, construction partners, and local workforce development programs. Apple Chief Operating Officer Sabi Khan emphasized the extraordinary effort required to achieve this early completion. Our teams have done an incredible job accelerating work to get the new Houston factory up and running ahead of schedule. And we plan to continue expanding the facility to increase production next year. This expansion strategy indicates Apple's confidence in the facility's operational model and its commitment to scaling domestic production capacity. Partnership with Foxconn. The Houston facility operates through a strategic partnership with Foxconn, formerly known as Han High Precision Industry Company Limited. Foxconn's involvement extends beyond simple manufacturing execution. The company acquired the 118-acre Fairbanks Logistics Park in Houston for $142 million, planning to invest up to $450 million in developing an AI server manufacturing facility. This four-building, 1 million square foot industrial campus provides the physical infrastructure necessary to support Apple's ambitious production goals. Foxconn's presence in Houston creates synergies beyond Apple's operations. The company also manufactures components for NVIDIA's AI supercomputers at adjacent facilities, positioning Houston as a critical node in America's AI infrastructure supply chain. This concentration of advanced manufacturing expertise creates a regional ecosystem that benefits from shared knowledge, workforce development, and supply chain optimization. Workforce development and employment impact. The Houston facility is projected to create thousands of direct jobs, with the broader economic impact extending to indirect employment throughout the supply chain. Apple has implemented comprehensive workforce development strategies to staff the facility, including partnerships with local contractors and recruitment programs coordinated with Houston City College. These partnerships ensure that local residents have access to training programs that prepare them for high-skilled manufacturing positions in advanced technology production. The Greater Houston Partnership, the region's largest chamber of commerce, estimates that the combined impact of Apple's facility and related Foxconn operations will create 600 direct jobs, 814 indirect jobs, and generate an estimated $920 million economic impact on the region. These figures underscore the transformative potential of advanced manufacturing reshoring for local economies, particularly in regions with existing industrial infrastructure and educational institutions capable of supporting workforce development. Technical specifications and capabilities. Apple's custom silicon architecture. The servers manufactured in Houston are equipped with Apple's proprietary silicon chips, representing a fundamental departure from industry-standard server architectures. While specific technical specifications remain closely guarded, industry analysts suggest these servers utilize variants of Apple's M-series chips, potentially including specialized configurations optimized for AI workloads. Apple has been developing custom server chips, codenamed Bultra, designed specifically for AI inference workloads, potentially featuring configurations that scale beyond the consumer-focused M-series chips. The use of Apple silicon provides several strategic advantages. First, vertical integration allows Apple to optimize hardware and software in tandem, maximizing performance efficiency for specific AI workloads. Second, custom silicon enables Apple to implement hardware-level security features that extend the privacy protections of its consumer devices to cloud infrastructure. Third, designing its own chips reduces dependency on third-party suppliers and provides greater control over the supply chain, a critical consideration in the current geopolitical environment. Industry reports suggest Apple's future server chips may feature significantly expanded core counts compared to consumer variants. Development roadmaps indicate potential configurations with 2 times, 4 times, and 8 times the CPU and GPU core counts of the M3 Ultra processor, which features 32 CPU cores and 80 GPU cores. This scaling would enable configurations with up to 256 CPU cores and 640 GPU cores for specialized AI server applications. Such specifications would position Apple servers competitively against specialized AI chips from companies like NVIDIA, Google, and Amazon Private Cloud Compute Architecture. The servers manufactured in Houston serve as the physical foundation for Private Cloud Compute, PCC, Apple's groundbreaking approach to cloud-based AI processing. PCC extends Apple's device-level security model into the cloud infrastructure, maintaining the privacy standards users expect from Apple products, while enabling computationally intensive AI operations that exceed on-device capabilities. Private cloud compute operates on 5 core principles that distinguish it from traditional cloud AI platforms. First, stateless computation ensures that user data is processed solely for the immediate request and is not retained after completion. Second, enforceable guarantees mean that security and privacy protections are technically enforced rather than merely promised through policy. Third, no privileged runtime access prevents even Apple's own system administrators from bypassing privacy protections. Non-targetability ensures that attackers cannot direct requests to specific servers for exploitation. Fifth, verifiable transparency allows independent researchers to inspect and verify the system's security claims. The technical implementation of these principles required custom-built server hardware that combines Apple Silicon, secure enclave security processors, and secure boot mechanisms running on a hardened operating system. This operating system represents a stripped-down subset of iOS and macOS foundations, specifically tailored for large language model inference workloads, while presenting an extremely narrow attack surface. Significantly, Apple excluded components traditionally critical to data center administration, such as remote shells and system introspection tools, replacing them with purpose-built components that provide only a restricted set of operational metrics. AI processing and Apple Intelligence features. The Houston-manufactured servers power Apple Intelligence, the company's suite of AI-powered features integrated across iPhone, iPad, and Mac devices. Apple Intelligence provides capabilities including advanced writing tools for text generation and summarization, Image Playground for visual content creation, Genmoji for custom emoji generation, enhanced Siri functionality with deeper app integration and on-screen awareness, and visual intelligence for camera-based information lookup and processing. The architecture employs a hybrid approach where simple AI tasks execute on-device using the neural engine built into Apple Silicon, while more complex computations requiring larger language models are securely offloaded to private cloud compute servers. This hybrid model balances performance, privacy, and energy efficiency, enabling sophisticated AI capabilities without compromising the privacy protections fundamental to Apple's value proposition. When an iPhone or Mac determines that a request requires cloud processing, the data is transmitted to PCC servers through an encrypted channel. The server processes the request in a stateless manner, meaning no user data persists after the session completes. The server's operating system runs in a write-protected configuration with no persistent storage, ensuring that data is cryptographically unrecoverable after system reboots. This architecture provides cloud-scale AI processing power while maintaining device-level privacy protections. The $600 billion American investment commitment. Investment breakdown and allocation. Apple's commitment to the United States has expanded from an initial $500 billion announcement in February 2025 to $600 billion in August 2025, following a meeting between CEO Tim Cook and President Trump. This comprehensive investment spans multiple categories, representing one of the largest private sector commitments to domestic manufacturing and technology development in American history. The investment encompasses several major components: advanced manufacturing facilities, including the Houston server factory, represent a significant portion of the commitment. Silicon engineering and semiconductor partnerships, particularly the expanded collaboration with TSMC's Arizona fabrication facilities, constitute another major allocation. Research and development expenditures, including the creation of approximately 20,000 new R&D jobs focused on silicon engineering, software development, and AI machine learning, represent substantial ongoing investments. Content production for Apple TV Plus across 20 states contributes to the domestic creative economy. The Advanced Manufacturing Fund expansion from $5 billion to $10 billion supports supplier development and domestic component production. Manufacturing education initiatives, including a new manufacturing academy in Michigan, build workforce capabilities for advanced manufacturing. The financial scope of this commitment reflects multiple accounting methodologies. The figure includes direct capital expenditures on facilities and equipment, operational expenditures for research and development activities, payments to domestic suppliers for components and services, and employment costs for new hires. Some analysts note that the 4-year commitment includes ongoing operational costs that Apple would incur regardless of location decisions, suggesting that the incremental new investments specifically driven by reshoring represents a smaller, though still substantial, figure American manufacturing program. In August 2025, Apple launched the American Manufacturing Program, AMP, a dedicated initiative to incentivize suppliers and partners to expand domestic manufacturing operations. Through AMP, Apple works with 10 companies across America to produce components used in Apple products sold globally. Approximately 2/3 of components manufactured in the United States are exported to customers outside the U.S., demonstrating that domestic manufacturing can support global market competitiveness. Key partners in the American Manufacturing Program include Corning, which receives $2.5 billion for expanding glass production for iPhones and Apple Watches in Kentucky, Taiwan's semiconductor manufacturing company, TSMC, receiving multi-billion-dollar commitments for advanced silicon production at Arizona facilities, Coherent, producing advanced optical components, Applied Materials, supplying semiconductor manufacturing equipment, Texas Instruments, producing semiconductor components, Samsung, Global Foundries, and Amkor, contributing to the semiconductor supply chain, and Broadcom, developing specialized chips for Apple applications. The American Manufacturing Program addresses a critical challenge in reshoring: the need for comprehensive supply chain reconfiguration. Manufacturing complex technology products requires extensive supplier networks, providing specialized components, materials, and services. By incentivizing multiple suppliers to establish or expand domestic operations simultaneously, Apple creates the ecosystem necessary to support sustainable domestic production. This approach contrasts with isolated reshoring efforts that often fail due to lack of domestic supplier infrastructure. Semiconductor production and TSMC partnership. Apple's semiconductor strategy represents a cornerstone of its domestic manufacturing commitment. The company has established a multi-billion-dollar commitment to produce advanced silicon at TSMC's Fab 21 facility in Phoenix, Arizona, making Apple the largest customer at TSMC's Arizona operations. TSMC began mass production of Apple chips using 4-nanometer process technology in January 2025, marking the first production of cutting-edge semiconductor chips on American soil in decades. TSMC's Arizona investment has expanded dramatically in response to strategic imperatives and government incentives provided through the CHIPS and Science Act. The company's total investment now exceeds $65 billion for a multi-fab campus, with plans for 6 fabrication plants, 2 advanced packaging facilities, and a research and development center. The first fab produces 4-nanometer chips, while subsequent facilities will manufacture 3-nanometer chips, targeted for 2028, and 2-nanometer chips, targeted for 2029. This domestic semiconductor production provides critical strategic advantages. It reduces Apple's exposure to geopolitical risks associated with concentrating advanced chip manufacturing in Taiwan, a region facing increasing tensions with China. It aligns with U.S. government priorities for semiconductor supply chain resilience and national security. It positions Apple favorably for potential future trade restrictions or tariffs on imported semiconductors. Finally, it contributes to rebuilding America's semiconductor manufacturing ecosystem, which has eroded significantly over recent decades. Political context and presidential support. Trump administration's manufacturing agenda. President Donald Trump has made reshoring manufacturing a central priority of his administration, implementing policies designed to incentivize domestic production and penalize offshoring. These policies include tariffs on imported goods, particularly from China, creating cost pressures that make domestic production more competitive. Regulatory reforms aimed at reducing barriers to domestic manufacturing. Tax incentives for capital investment in domestic facilities, including immediate expensing provisions. And political pressure on major corporations to increase domestic production, often through public statements and meetings with CEOs. Apple's announcement arrived at a strategically significant moment as the Trump administration continues pushing manufacturers to bring operations back to American shores. The October 2025 server shipment announcement followed closely on the heels of National Manufacturing Day proclamations and ongoing tariff implementations designed to protect domestic manufacturing. Fox Business reported that Apple's Houston facility began operations in response to Trump's aggressive push to get these projects online as soon as possible. The White House issued a press release specifically highlighting Apple's commitment, with President Trump stating, "For years, Americans have watched as many of our leading tech giants built their factories overseas and exported American jobs abroad. We're doing everything possible to make this the best place on earth to build a factory or grow businesses." This public endorsement reflects the administration's strategy of leveraging announcements from major corporations to validate its economic policies and demonstrate tangible results from its manufacturing agenda. Strategic meetings and policy alignment. The relationship between Apple and the Trump administration has evolved through a series of high-level meetings and announcements. In February 2025, following a meeting between Tim Cook and President Trump, Apple announced the initial $500 billion investment commitment, including plans for the Houston server facility. In August 2025, following another meeting, Apple increased its commitment to $600 billion and announced the American Manufacturing Program. At this meeting, Cook presented Trump with a gift of Corning glass used in iPhones and Apple Watches, symbolizing Apple's commitment to American-made components. These meetings serve multiple strategic purposes for both parties. For Apple, public alignment with the administration's manufacturing priorities provides political capital that may prove valuable in future policy discussions, particularly regarding tariffs, trade policy, and regulatory matters. The company faces ongoing pressure regarding iPhone assembly, which remains predominantly located in China, with approximately 80% of iPhones sold in the United States still manufactured overseas. By demonstrating substantial domestic investment in strategically important server infrastructure and semiconductor components, Apple builds goodwill while addressing areas where domestic production is most technically and economically feasible. For the Trump administration, Apple's announcements provide concrete evidence supporting claims that reshoring policies are working. The scale of Apple's commitment, $600 billion over 4 years, ranks among the largest corporate domestic investment pledges in American history. Trump has described it as among the greatest investment booms in our nation's history. These announcements provide political messaging opportunities that support the administration's broader economic narrative, particularly important during election cycles and policy debates. Tariff considerations and trade policy. Tariffs have fundamentally altered the economic calculus for Apple's manufacturing location decisions. The Trump administration imposed 10% tariffs on many goods assembled in China, with the potential for additional tariffs of 25% or higher on specific product categories. During Trump's first term, Apple secured waivers from similar tariffs, but the company appears to be pursuing a strategy of reducing tariff exposure through increased domestic production rather than relying on continued exemptions. The financial impact of tariffs differs significantly between finished products and components. When Apple imports completed assemblies or finished products, tariffs apply to the entire value, substantially increasing costs. However, by manufacturing in the United States and importing only components, tariffs apply solely to those imported parts, rather than the full product value, often resulting in significant cost savings. For servers manufactured in Houston, this means tariffs apply only to imported components, like certain chips, memory modules, or specialized parts, rather than the entire finished server. The reshoring decision also provides insurance against future tariff escalations. Political rhetoric suggests potential for further trade restrictions, particularly on technology products. By establishing domestic manufacturing capabilities for strategic products like AI servers, Apple reduces vulnerability to sudden policy changes that could dramatically impact cost structures or supply chain continuity. This risk management consideration may justify reshoring even in cases where direct cost comparisons slightly favor overseas production. Economic and industry implications. Impact on Houston and regional economy. Houston has emerged as a significant beneficiary of the technology manufacturing reshoring trend, with multiple major companies selecting the region for advanced manufacturing operations. Beyond Apple's server facility, Foxconn's broader AI server manufacturing campus, NVIDIA's AI supercomputer component manufacturing facility, also in partnership with Foxconn, and related supplier operations, create a concentration of high-tech manufacturing expertise. The Greater Houston Partnership, the region's largest chamber of commerce, has actively recruited these investments by promoting Houston's competitive advantages. A business-friendly regulatory environment with lower operating costs than many coastal technology hubs. A skilled and diverse workforce of nearly 240,000 manufacturing workers. Robust infrastructure, including the nation's busiest port for foreign tonnage, 2 international airports, and extensive highway and rail networks. proximity to energy resources and related industrial expertise, and industry-aligned training programs at local colleges and universities. The cumulative economic impact extends beyond direct employment at these facilities. Multiplier effects generate additional jobs in supporting industries, including component suppliers, logistics and transportation services, maintenance and facility management, food service and retail serving the workforce, and construction for ongoing facility expansion. The $920 million economic impact estimate for the Foxconn facility alone suggests that the broader cluster of AI manufacturing operations could generate several billion dollars in annual regional economic activity, reshoring trends, and manufacturing renaissance. Apple's Houston facility represents part of a broader reshoring trend, accelerating across American manufacturing. The Reshoring Initiative, an organization tracking manufacturing location decisions, reports that reshoring and foreign direct investment announcements have grown substantially in recent years, though 2025 data shows some moderation in growth rates compared to peak years. Multiple factors drive this reshoring acceleration. Supply chain disruptions during the COVID-19 pandemic exposed vulnerabilities in global supply chains, particularly dependence on single-source suppliers or geographically concentrated production. Companies experienced extended delays at ports, container shipping shortages, and inability to respond to demand fluctuations. These experiences motivated many companies to prioritize supply chain resilience over marginal cost savings. Transportation costs have risen significantly, reducing the cost advantage of distant manufacturing locations. Container shipping rates spiked dramatically during pandemic-related disruptions, and, while somewhat moderated, remain elevated compared to historical norms. Rising fuel costs further increase transportation expenses. For time-sensitive or rapidly changing products, the working capital costs of extended transit times, typically 4 to 6 weeks from Asia versus days within North America, represent substantial hidden expenses. Quality control considerations favor proximity manufacturing. Domestic production enables more frequent supplier audits, faster problem resolution when quality issues arise, tighter integration between design and manufacturing teams, and reduced risk of intellectual property theft in jurisdictions with weak IP protections. For complex products like AI servers, where performance, reliability, and security are critical, these quality control advantages may outweigh cost differences. Challenges and limitations of reshoring. Despite growing momentum, reshoring faces substantial challenges that limit its scope and pace. Labor costs in the United States significantly exceed those in many offshore manufacturing locations. While automation can offset some labor cost disadvantages, not all manufacturing processes are equally amenable to automation. Labor-intensive assembly operations, particularly for consumer electronics like smartphones, remain economically challenging to reshore at current wage levels. The United States faces significant skilled labor shortages in manufacturing. Decades of offshoring and cultural emphasis on 4-year college degrees over technical training have depleted the manufacturing workforce. Finding qualified technicians, engineers, and operators for advanced manufacturing operations requires extensive recruitment and training programs. Apple's partnership with Houston City College and the Manufacturing Academy in Michigan address this challenge, but workforce development requires sustained, long-term investment. Supply chain reconfiguration represents a complex, time-intensive challenge. Manufacturing complex products requires extensive supplier networks. Many specialized components, materials, and sub-assemblies lack domestic suppliers with sufficient capacity, quality, or cost competitiveness. Building a comprehensive domestic supply chain requires coordinated investment across multiple tiers of suppliers, a process that may take years or decades for complex product categories. Capital requirements for advanced manufacturing facilities are substantial. Modern semiconductor fabs can cost $10 to $20 billion or more. Even less capital-intensive facilities require hundreds of millions in investment. These capital requirements create barriers to entry and long payback periods that may discourage reshoring investments, particularly for smaller companies without Apple's financial resources. Samsung Galaxy XR, a comprehensive analysis of the mixed reality headset launch and Google partnership. Executive Summary. Samsung Electronics officially unveiled the Galaxy XR mixed reality headset on October 21, 2025, marking the company's ambitious entry into the extended reality market and the beginning of a transformative partnership with Google and Qualcomm Technologies. Priced at $1,799, the Galaxy XR represents the first consumer device built on Google's new Android XR platform, positioning itself as a formidable competitor to Apple's Vision Pro and Meta's Quest lineup. The launch generated substantial media attention, with technology publications, industry analysts, and consumers closely examining how this collaboration could reshape the competitive landscape of mixed reality computing. As the inaugural device in what Samsung describes as a long-term XR journey, the Galaxy XR showcases multimodal artificial intelligence at its core, powered by Google's Gemini AI assistant and Qualcomm's Snapdragon XR2 Plus Gen 2 chipset. This document provides an in-depth examination of the Galaxy XR launch, exploring the strategic partnership between Samsung and Google, the technical specifications and features of the headset, the broader Android XR ecosystem, competitive positioning against rivals, enterprise and consumer applications, and the future roadmap, including AI-powered smart glasses. The analysis draws on official announcements, technical documentation, media coverage, and industry expert assessments to present a comprehensive overview of this significant development in the mixed reality market. The strategic partnership, Samsung, Google, and Qualcomm. 1.1 Genesis of the collaboration. The partnership between Samsung, Google, and Qualcomm in the extended reality space was first publicly announced in February 2023 during Samsung's Galaxy S23 launch event. At that time, the collaboration was described in vague terms, with executives from Qualcomm in certain industries and extension teams. The partnership between Samsung, Google, and Qualcomm in the extended reality space was first publicly announced in February 2023. All three companies promising new hardware and software that would bring unprecedented XR experiences to consumers. The announcement came at a critical juncture, when both Samsung and Google had stepped away from their earlier VR efforts. Samsung had discontinued its Gear VR headsets, and Google had shelved both Google Cardboard and Daydream VR platforms. However, Google never completely abandoned its XR ambitions. According to Samir Samat, president of Android ecosystem at Google, the company never stopped working on XR despite these public failures, and the emergence of the Gemini era meant the time is right for XR. Internally, Google had been developing Project Iris, an augmented reality headset powered by a new operating system, though this project was eventually shelved after Apple released the Vision Pro in 2024. The collaboration was revived and formalized around the development of Android XR, a completely new operating system designed specifically for extended reality devices from the ground up. Unlike previous efforts that attempted to adapt existing mobile operating systems for XR use, Android XR was conceived as the first Android platform built entirely for the Gemini era of artificial intelligence. 1.2 Division of Responsibilities. The partnership features a clear division of responsibilities that leverages each company's core competencies. Samsung Electronics assumed primary responsibility for hardware design and manufacturing, drawing on its extensive experience in consumer electronics, display technology, and mobile device production. The company's expertise in premium smartphone manufacturing translated directly to the challenges of creating a sophisticated mixed reality headset with high-resolution displays and advanced sensor arrays. Google contributed the software foundation through Android XR, the operating system that powers the Galaxy XR and will support future devices in the ecosystem. This represents Google's return to the XR market with a comprehensive platform approach, integrating the company's strength in software development, artificial intelligence, and cloud services. Google's Gemini AI serves as the central intelligence layer, embedded at the system level rather than as an add-on feature, enabling contextual understanding and multimodal interactions. Qualcomm Technologies provided the silicon that powers the experience through its Snapdragon XR2 Plus Gen 2 platform, specifically designed for premium mixed reality headsets. This chipset represents the cutting edge of mobile XR processing, offering enhanced GPU and CPU performance compared to its predecessors, support for ultra-high-resolution displays, and advanced AI processing capabilities. Qualcomm also contributed its Snapdragon Spaces technology, which provides developers with tools to create enterprise applications for the Android XR platform. Strategic objectives. The partnership serves distinct strategic objectives for each participant. For Samsung, the Galaxy XR represents an opportunity to establish a foothold in what the company sees as the next major computing platform after smartphones and tablets. Won Jun Choi, Chief Operating Officer of Mobile Experience Business at Samsung Electronics, stated, "With Galaxy XR, Samsung is introducing a brand new ecosystem of mobile devices. Built on Android XR, Galaxy XR expands the vision for mobile AI into a new frontier of immersive and meaningful possibilities. For Google, Android XR provides a vehicle to extend its Android ecosystem into spatial computing, potentially replicating the success it achieved in mobile phones and tablets." The company views XR as fundamentally different from earlier attempts because artificial intelligence, particularly large language models like Gemini, can now serve as a natural interface for complex three-dimensional environments. Shara Mizadi, Vice President and General Manager of Android XR at Google, positioned the launch as a first look at this new way of interacting with technology. Qualcomm's participation reinforces its position as the leading provider of processors for mobile XR devices, similar to its dominance in smartphone chipsets. Alex Katuzian, Group General Manager of Mobile, Compute, and XR at Qualcomm Technologies, emphasized, "Galaxy XR embodies our vision for the future, where the synergy of AI and XR transforms the possibilities of personal computing. Long-term vision. The partnership extends beyond a single headset to encompass a broader vision for XR across multiple form factors. At the Galaxy XR launch event, Samsung executives repeatedly emphasized that the headset represents just the beginning of a long-term XR roadmap that includes AI-powered smart glasses, lighter mixed reality devices, and potentially other form factors yet to be announced. This multi-device strategy mirrors the successful collaboration between Samsung and Google on smartwatches, which began in 2021 and led to a rethinking of Google's wearable platform and the eventual release of the Pixel Watch. The XR partnership appears designed to follow a similar trajectory, with Samsung creating reference hardware that demonstrates the capabilities of Android XR, while Google develops the platform to support devices from multiple manufacturers. The long-term vision also includes partnerships with eyewear companies Warby Parker and Gentle Monster to develop AI-powered smart glasses that will bring Android XR capabilities to lightweight, everyday wearables. These collaborations target different market segments. Gentle Monster will develop fashion-forward glasses for the high-end market, while Warby Parker will create eyewear for mainstream consumers at more accessible price points. Android XR, a new operating system for spatial computing platform, architecture, and design philosophy. Android XR represents a fundamental reimagining of how operating systems should work in three-dimensional space. Unlike previous attempts to adapt mobile operating systems for XR use, Android XR was designed from the ground up as a spatial computing platform built on open standards including OpenXR, WebXR, and Vulkan. This architecture allows developers to create experiences that work across multiple XR devices while minimizing the need for platform-specific code. The platform's design philosophy centers on three core principles: openness, AI-native experiences, and natural interactions. The openness aspect manifests in support for industry-standard APIs and developer tools, ensuring that applications built for Android XR can potentially run on devices from multiple manufacturers. This contrasts with Apple's approach with Vision OS, which creates a closed ecosystem tied exclusively to Apple hardware. Google positioned Android XR as the first Android platform built entirely for the Gemini era, signaling that artificial intelligence is not merely a feature, but the foundational organizing principle of the operating system. Gemini AI is embedded at the system level, with the ability to see what users see through the headset's cameras and hear what they hear through its microphones, enabling contextual assistance throughout the user experience. How this collaboration could reshape the competitive landscape of mixed reality computing. As the inaugural device in what Samsung describes as a long-term XR journey, the Galaxy XR showcases multimodal artificial intelligence at its core, powered by Google's Gemini AI assistant and Qualcomm's Snapdragon XR2 Plus Gen 2 chipset. This document provides an in-depth examination of the Galaxy XR launch, exploring the strategic partnership between Samsung and Google, the technical specifications and features of the headset, the broader Android XR ecosystem, competitive positioning against rivals, enterprise and consumer applications, and the future roadmap including AI-powered smart glasses. The analysis draws on official announcements, technical documentation, media coverage, and industry expert assessments to present a comprehensive overview of this significant development in the mixed reality market. The strategic partnership: Samsung, Google, and Qualcomm. 1.1 Genesis of the collaboration. The partnership between Samsung, Google, and Qualcomm in the extended reality space was first publicly announced in February 2023 during Samsung's Galaxy S23 launch event. At that time, the collaboration was described in vague terms, with executives from Questions, all three companies promising new hardware and software that would bring unprecedented XR experiences to consumers. The announcement came at a critical juncture when both Samsung and Google had stepped away from their earlier VR efforts. Samsung had discontinued its Gear VR headsets, and Google had shelved both Google Cardboard and Daydream VR platforms. However, Google never completely abandoned its XR ambitions. According to Samir Samat, president of Android ecosystem at Google, the company never stopped working on XR. Despite these public failures, and the emergence of the Gemini era meant the time is right for XR. Internally, Google had been developing Project Iris, an augmented reality headset powered by a new operating system. Though this project was eventually shelved after Apple released the Vision Pro in 2024, the collaboration was revived and formalized around the development of Android XR, a completely new operating system designed specifically for extended reality devices from the ground up. Unlike previous efforts that attempted to adapt existing mobile operating systems for XR use, Android XR was conceived as the first Android platform built entirely for the Gemini era of artificial intelligence. 1.2 Division of Responsibilities. The partnership features a clear division of responsibilities that leverages each company's core competencies. Samsung Electronics assumed primary responsibility for hardware design and manufacturing, drawing on its extensive experience in consumer electronics, display technology, and mobile device production. The company's expertise in premium smartphone manufacturing translated directly to the challenges of creating a sophisticated mixed reality headset with high-resolution displays and advanced sensor arrays. Google contributed the software foundation through Android XR, the operating system that powers the Galaxy XR and will support future devices in the ecosystem. This represents Google's return to the XR market with a comprehensive platform approach, integrating the company's strength in software development, artificial intelligence, and cloud services. Google's Gemini AI serves as the central intelligence layer, embedded at the system level rather than as an add-on feature, enabling contextual understanding and multimodal interactions. Qualcomm Technologies provided the silicon that powers the experience through its Snapdragon XR2 Plus Gen 2 platform, specifically designed for premium mixed reality headsets. This chipset represents the cutting edge of mobile XR processing, offering enhanced GPU and CPU performance compared to its predecessors, support for ultra-high resolution displays, and advanced AI processing capabilities. Qualcomm also contributed its Snapdragon Spaces technology, which provides developers with tools to create enterprise applications for the Android XR platform. User interface and interaction paradigms. The Android XR interface introduces new interaction paradigms that blend physical and digital elements in three-dimensional space. Users can navigate through a combination of eye tracking, hand gestures, and voice commands, creating a multimodal interaction model that adapts to different contexts and user preferences. The system supports both fully immersive virtual environments, and mixed reality experiences where digital content appears integrated with the physical world through high-resolution pass-through video. Galaxy XR offers what Samsung and Google describe as an infinite screen for applications, allowing users to position and resize windows in three-dimensional space around them. This spatial interface eliminates the physical constraints of traditional screens, enabling users to work with multiple applications simultaneously in a room-scale environment. The interface maintains familiar Android design elements, making it intuitive for users already comfortable with Android smartphones and tablets. Eye tracking plays a central role in navigation, with the system detecting where users are looking to provide visual feedback and enable selection through gaze combined with hand gestures. This creates a more natural interaction model than traditional controller-based navigation. Though Samsung also offers optional controllers for applications like games that benefit from physical input devices. Application ecosystem and developer tools. One of Android XR's most significant advantages is immediate access to millions of existing Android applications from Google Play. All apps built on the Android platform work out of the box on Galaxy XR without requiring modifications from developers, providing instant content availability that new platforms typically struggle to achieve. These 2D applications appear as floating windows in the user space, while developers can enhance them with spatial features to create more immersive experiences. For developers who want to create XR-specific experiences, Android XR provides multiple development pathways. The Android XR SDK supports development with Android Jetpack XR for native Android development, Unity for game and 3D content creation, OpenXR for cross-platform XR applications, and WebXR for browser-based experiences. This flexibility reduces the learning curve and allows developers to use familiar tools rather than learning entirely new frameworks. Google showcased several categories of applications optimized for Android XR at launch. These include reimagined versions of Google's own apps, such as Google Maps with immersive 3D navigation, YouTube with AI-powered content discovery, Google Photos with auto-spatialized 3D viewing, and Chrome for spatial web browsing. Third-party content partners announced over 50 XR exclusive experiences from companies including Adobe, Calm, Fox Sports, MLB, Crunchyroll, HBO Max, and Peacock. The platform also supports OpenXR 1.1 specification and vendor extensions, ensuring compatibility with applications developed for other XR platforms that use industry-standard APIs. This cross-platform compatibility significantly expands the potential application library and reduces fragmentation in the XR development ecosystem. Gemini AI integration. The integration of Google's Gemini AI represents the most distinctive aspect of Android XR. Gemini functions as a persistent, context-aware companion that can understand and respond to what users are experiencing in both the physical and virtual worlds. This multimodal perception system uses the headset's cameras and microphones to contextualize user interactions, allowing Gemini to provide assistance that goes far beyond traditional voice assistance. In practice, Gemini can answer questions about video content being watched, provide real-time coaching during games, offer turn-by-turn navigation suggestions while exploring virtual environments in Google Maps, and help organize the user's workspace by arranging windows and applications. The AI can also use the circle-to-search feature in pass-through mode, allowing users to point at real-world objects and receive instant information about them. Gemini Live enables natural conversation with the AI assistant, with users able to ask follow-up questions and receive contextually relevant responses based on their current activity and environment. This represents a significant evolution from traditional menu-based interfaces, moving toward what Google calls conversational workspace interactions, where users can simply talk to their headset to accomplish tasks. The deep AI integration also enables features like auto-spatialization of 2D photos and videos, transforming flat media into three-dimensional experiences with added depth and dimension. Google's media auto-spatialization technology analyzes 2D content and generates depth information to create more immersive viewing experiences without requiring content creators to shoot in 3D formats. Technical specifications and hardware design, display technology, and visual performance. The Galaxy XR features dual micro OLED displays with a resolution of 3,552 by 3,840 pixels per eye, totaling approximately 29 million pixels across both eyes. This resolution translates to a pixel density of 4,032 pixels per inch, which exceeds the 3,386 ppi offered by Apple's Vision Pro. The high pixel density minimizes the screen door effect, the visible gaps between pixels, that can break immersion in lower resolution headsets, and provides crisp, clear visuals for both virtual content and pass-through video. The displays cover 96% of the DCI P3 color gamut, ensuring vibrant and accurate color reproduction for entertainment and professional applications. Refresh rates are configurable at 60 Hz, 72 Hz default, and 90 Hz, with the system defaulting to 72 Hz to balance visual smoothness with battery conservation. While the maximum 90 Hz refresh rate is lower than the Vision Pro's 120 Hz capability, it provides sufficient performance for most mixed reality applications while reducing power consumption. The field of view measures 109 degrees horizontally and 100 degrees vertically, offering an expansive visual experience that approaches the limits of human peripheral vision. This wide field of view creates a more immersive experience compared to narrower headsets, allowing users to better perceive their virtual and physical surroundings without excessive head movement. Processing power and performance. At the heart of the Galaxy XR sits Qualcomm's Snapdragon XR2 Plus Gen 2 platform, a premium variant of the chipset used in Meta's Quest 3 headset. The Plus suffixed version offers 15% higher GPU frequency and 20% higher CPU frequency compared to the standard XR2 Gen 2, enabling it to drive the headset's ultra-high-resolution displays while maintaining smooth performance. The chipset features 6 CPU cores running at up to 2.4 GHz across all cores, paired with an Adreno GPU optimized for XR rendering techniques, including dynamic foveated rendering, space warp, and game super resolution. These advanced rendering techniques allow the system to deliver visually impressive experiences while managing power consumption. Foveated rendering, for example, renders the area where the user is looking at full resolution while reducing detail in peripheral vision, significantly improving performance without noticeable quality loss. The Galaxy XR includes 16 GB of RAM and 256 GB of storage, providing ample memory for multitasking between applications and storing XR content locally. This memory configuration matches or exceeds competing premium headsets and ensures smooth performance when running multiple applications simultaneously in the spatial interface. The Hexagon NPU, Neural Processing Unit, within the Snapdragon XR2 Plus Gen 2, delivers 8 times more AI performance compared to the original Snapdragon XR2 Gen 1, enabling on-device processing for AI features including Gemini's contextual understanding, hand and eye tracking, facial expression monitoring, depth estimation, and 3D reconstruction. This on-device AI processing reduces latency and enhances privacy by minimizing the need to send data to cloud servers for processing. Sensors and tracking systems. The Galaxy XR incorporates an extensive sensor suite designed to enable accurate tracking and natural interactions. The headset features 2 high-resolution pass-through cameras that capture full-color video of the user's environment with less than 12 milliseconds of end-to-end latency. This low latency is crucial for mixed reality applications, as higher latency can cause disorientation and discomfort when virtual content doesn't align properly with physical movement. 6 world-facing tracking cameras provide inside-out positional tracking, allowing the headset to determine its precise location and orientation in 3-dimensional space without requiring external sensors or base stations. This enables room-scale experiences where users can move freely while the system maintains accurate tracking of their position. 4 eye-tracking cameras monitor the user's gaze, enabling foveated rendering for performance optimization and providing an intuitive navigation method through gaze-based selection. The eye-tracking system also supports iris recognition for secure device unlocking and password autofill in certain applications, adding a biometric security layer similar to fingerprint or face recognition on smartphones. 5 inertial measurement units, IMUs, precisely track head movements and orientation, while a dedicated depth sensor enables accurate 3D mapping of the environment for spatial anchoring of virtual content. A flicker sensor detects artificial lighting frequencies to reduce visual artifacts in pass-through video when operating under fluorescent or LED lighting. The headset's external camera can capture 3D photos and videos at up to 6.5 megapixels with an 18mm f2.0 lens, allowing users to create their own spatial content. This content capture capability positions the Galaxy XR not just as a consumption device, but as a tool for creating immersive media that can be shared and experienced by other XR users. Technical specifications and hardware design, display technology and visual performance. The Galaxy XR features dual micro OLED displays with a resolution of 3552 by 3840 pixels per eye, totaling approximately 29 million pixels across both eyes. This resolution translates to a pixel density of 4032 pixels per inch, which exceeds the 3386 ppi offered by Apple's Vision Pro. The high pixel density minimizes the screen door effect, the visible gaps between pixels that can break immersion in lower resolution headsets, and provides crisp, clear visuals for both virtual content and pass-through video. The displays cover 96% of the DCI P3 color gamut, ensuring vibrant and accurate color reproduction for entertainment and professional applications. Refresh rates are configurable at 60 Hz, 72 Hz, default, and 90 Hz, with the system defaulting to 72 Hz to balance visual smoothness with battery conservation. While the maximum 90 Hz refresh rate is lower than the Vision Pro's 120 Hz capability, it provides sufficient performance for most mixed reality applications, while reducing power consumption. The field of view measures 109 degrees horizontally and 100 degrees vertically, offering an expansive visual experience that approaches the limits of human peripheral vision. This wide field of view creates a more immersive experience compared to narrower headsets, allowing users to better perceive their virtual and physical surroundings without excessive head movement. Processing power and performance. At the heart of the Galaxy XR sits Qualcomm's Snapdragon XR2 Plus Gen 2 platform, a premium variant of the chipset used in Meta's Quest 3 headset. The Plus suffixed version offers 15% higher GPU frequency and 20% higher CPU frequency compared to the standard XR2 Gen 2, enabling it to drive the headset's ultra-high-resolution displays while maintaining smooth performance. The chipset features 6 CPU cores running at up to 2.4 GHz across all cores, paired with an Adreno GPU, optimized for XR rendering techniques, including dynamic foveated rendering, space warp, and game super resolution. These advanced rendering techniques allow the system to deliver visually impressive experiences while managing power consumption. Foveated rendering, for example, renders the area where the user is looking at full resolution, while reducing detail in peripheral vision, significantly improving performance without noticeable quality loss. The Galaxy XR includes 16 GB of RAM and 256 GB of storage, providing ample memory for multitasking between applications and storing XR content locally. This memory configuration matches or exceeds competing premium headsets and ensures smooth performance when running multiple applications simultaneously in the spatial interface. The Hexagon NPU, Neural Processing Unit, within the Snapdragon XR2 Plus Gen 2, delivers 8 times more AI performance compared to the original Snapdragon XR2 Gen 1, enabling on-device processing for AI features including Gemini's contextual understanding, hand and eye tracking, facial expression monitoring, depth estimation, and 3D reconstruction. This on-device AI processing reduces latency and enhances privacy by minimizing the need to send data to cloud servers for processing. Sensors and tracking systems. The Galaxy XR incorporates an extensive sensor suite designed to enable accurate tracking and natural interactions. The headset features 2 high-resolution pass-through cameras that capture full-color video of the user's environment with less than 12 milliseconds of end-to-end latency. This low latency is crucial for mixed reality applications, as higher latency can cause disorientation and discomfort when virtual content doesn't align properly with physical movement. 6 world-facing tracking cameras provide inside-out positional tracking, allowing the headset to determine its precise location and orientation in 3-dimensional space without requiring external sensors or base stations. This enables room-scale experiences, where users can move freely while the system maintains accurate tracking of their position. 4 eye-tracking cameras monitor the user's gaze, enabling foveated rendering for performance optimization and providing an intuitive navigation method through gaze-based selection. The eye-tracking system also supports iris recognition for secure device unlocking and password autofill in certain applications, adding a biometric security layer similar to fingerprint or face recognition on smartphones. 5. Inertial measurement units, IMUs, precisely track head movements and orientation, while a dedicated depth sensor enables accurate 3D mapping of the environment for spatial anchoring of virtual content. A flicker sensor detects artificial lighting frequencies to reduce visual artifacts in pass-through video when operating under fluorescent or LED lighting. The headset's external camera can capture 3D photos and videos at up to 6.5 megapixels with an 18mm f2.0 lens, allowing users to create their own spatial content. This content capture capability positions the Galaxy XR not just as a consumption device, but as a tool for creating immersive media that can be shared and experienced by other XR users. Comparison with Meta Quest 3. While the Galaxy XR competes with the Apple Vision Pro in the premium segment, it also faces comparison with Meta's Quest 3, which occupies the mainstream consumer VR market at approximately $500, less than one-third the price of Samsung's offering. This creates a challenging positioning dilemma for Samsung. The Galaxy XR costs too much to compete directly with Meta's accessible pricing, yet lacks some of the technical advantages that justify Apple's premium positioning. The Meta Quest 3, powered by the standard Snapdragon XR2 Gen 2 chipset, not the Plus variant, offers lower resolution displays and less computing power than the Galaxy XR. However, Meta has built a mature content ecosystem with thousands of VR-native games and applications, many exclusive to the Quest platform. Meta also includes controllers in the box at no additional cost, making the platform immediately accessible for gaming, a key use case for many VR adopters. Meta's dominance in the XR market is substantial, with the company holding 60.6% market share in the combined AR/VR and displayless smart glasses market during Q2 2025. Meta captured 50.8% of the AR/VR headset market, specifically in Q1 2025, and 74.6% across the full year 2024. This installed base creates network effects and developer mindshare that Samsung and Google must overcome. The Galaxy XR's advantages over Quest 3 include significantly higher display resolution, more powerful processing with the XR2 Plus Gen 2 versus standard XR2 Gen 2, deeper AI integration through Gemini, and access to the broader Android app ecosystem. However, whether these advantages justify a price difference of $1,300 remains an open question, particularly given that the Galaxy XR has struggled to achieve mainstream adoption at its $500 price point. To experience video content, gaming, and interactive media, the device's high-resolution displays and spatial audio system create an immersive environment for watching movies and shows on a virtual screen that can appear much larger than any physical television. Streaming services, including Netflix, YouTube, HBO Max, Crunchyroll, and Peacock, have made their content available on the platform, with users able to watch in fully immersive virtual environments or with pass-through enabled to maintain awareness of their physical surroundings. YouTube integration includes AI-powered features where users can ask Gemini to find specific content or provide information about videos being watched, creating a more interactive viewing experience. The auto-spatialization feature transforms 2D photos and videos into three-dimensional experiences with added depth, allowing users to relive memories in a more immersive format. Google Photos leverages this capability to present personal media libraries in new ways, while supporting native viewing of content captured in 3D by the headset's own cameras. Gaming on the Galaxy XR takes multiple forms. Immersive VR games from developers including Mirrorscape, Alchemy Labs, and Resolution Games provide native XR experiences. However, the decision to sell controllers separately creates challenges for certain game genres, particularly action games and first-person shooters that traditionally rely on physical controllers for precise input. Puzzle games, strategy titles, and other genres that work well with hand tracking may see stronger adoption. Sports viewing benefits from AI integration, with examples demonstrated including real-time coaching and statistics overlay during basketball highlights. Partnerships with organizations like MLB and Fox Sports aim to deliver immersive sports viewing experiences, potentially including multi-angle viewing and 3D overlays of player statistics and tactical information. Productivity and collaboration. Samsung and Google position the Galaxy XR as a productivity device that can replace or augment traditional computer monitors with an infinite virtual workspace. The spatial interface allows users to arrange multiple application windows in three-dimensional space, creating a room-scale desktop environment that eliminates the physical constraints of screen size. Google's productivity applications have been reimagined for XR, including Chrome for web browsing, Meet for video conferencing with avatar support, and Gmail for communication. The ability to work with these familiar applications in a spatial context could appeal to knowledge workers seeking to maximize screen real estate and minimize distractions. Virtual meetings through Google Meet can feature avatar representations of participants, allowing for more natural spatial positioning compared to traditional video grid layouts. However, the social acceptance of wearing a headset during video calls remains uncertain, and many colleagues may prefer to see a participant's actual face rather than an avatar. The Circle to Search feature provides unique productivity benefits in mixed reality mode, enabling users to point at physical objects or information in their environment and instantly receive AI-powered information. This could support use cases ranging from quick reference during repair tasks to translation of foreign language text in the physical environment. Battery life limitations of 2 to 2.5 hours present challenges for extended productivity sessions, though the ability to use the device while charging mitigates this issue when near power outlets. The weight of the headset and strap system, while relatively light for an XR device, may still cause fatigue during all-day use compared to traditional monitors. Training and enterprise applications. Enterprise adoption represents a critical opportunity for the Galaxy XR, with several factors suggesting stronger near-term prospects in business contexts than consumer markets. Companies in healthcare, manufacturing, construction, and logistics are exploring XR solutions to improve training, reduce errors, enhance safety, and enable remote expertise. Samsung partnered with Samsung Heavy Industries to utilize the Galaxy XR for virtual shipbuilding training, addressing work productivity and safety in heavy industry. This partnership demonstrates real-world enterprise deployment in a complex manufacturing environment where training traditionally requires expensive physical mock-ups and carries inherent safety risks. Virtual training allows workers to practice procedures repeatedly in a safe environment before working with actual equipment and materials. Medical training applications showcase the platform's capabilities for high-stakes skill development. A partnership with Medtronic provides healthcare training simulations for medical procedures like intubation. Medical professionals can practice techniques and experience rare complications in a realistic virtual environment, improving preparedness for actual patient care scenarios. Qualcomm's Snapdragon Spaces technology provides developers with tools to create enterprise applications for Android XR, tapping into an existing ecosystem of business-focused XR solutions. Applications demonstrated include Campfire for shared design reviews, enabling distributed teams to collaborate on 3D models and prototypes in a shared virtual space. Retail and consumer goods companies are exploring XR for merchandising and planning. Mondelez International uses 3D planograms to visualize product placement before implementing store layouts. This allows retailers to test different arrangements virtually, optimizing product visibility and customer flow without the cost and disruption of physical reorganization. Maintenance and repair applications benefit from the ability to overlay digital information onto physical equipment. Demonstrated examples include ship engine maintenance applications that provide workers with step-by-step repair guidance overlaid on the actual machinery. This heads-up approach keeps workers hands-free while providing contextual information exactly when and where it's needed. The Android Enterprise Framework will be integrated into Android XR to enable app distribution, network configuration, security policies, and device management features required for large-scale enterprise deployments. This enterprise-grade management capability is essential for IT departments to maintain security and compliance when deploying XR devices across their organizations. The road ahead: smart glasses and future form factors. AI-powered smart glasses development. Samsung's XR strategy extends well beyond the Galaxy XR headset to include AI-powered smart glasses that could bring spatial computing capabilities to a lightweight, everyday wearable form factor. At the Galaxy XR launch event, Samsung confirmed it is developing smart glasses in collaboration with Google, with partnerships announced with eyewear companies Warby Parker and Gentle Monster. These smart glasses will run on the Android XR platform, creating a unified ecosystem where applications and experiences can work across different device types, from full mixed reality headsets to lightweight glasses. Jay Kim, head of customer experience at Samsung, stated, "We're working with two of the most forward-thinking brands in eyewear, Warby Parker and Gentle Monster, to introduce new devices that fit into your lifestyle." The partnership structure targets different market segments with distinct design approaches. Gentle Monster will develop fashion-forward glasses aimed at the high-end market, leveraging the brand's reputation for stylish, premium eyewear. These devices will likely command higher prices, but offer distinctive designs that appeal to fashion-conscious consumers for whom style is as important as functionality. Warby Parker's collaboration will focus on the mainstream market, creating eyewear at more accessible price points that appeal to a broader consumer base. Warby Parker's expertise in affordable, attractive eyewear, combined with Samsung and Google's technology, could produce smart glasses that compete directly with Meta's Ray-Ban partnership, which has found success in the consumer market. Competitive landscape for smart glasses. The smart glasses market is experiencing rapid growth and intense competition, with multiple technology companies rushing to establish positions in what many see as the next major computing platform. Meta's Ray-Ban smart glasses have achieved notable success, with the company recently introducing Ray-Ban display models that include screens for true extended reality experiences. International Data Corporation forecasts that smart glasses will drive significant market growth, with the category expected to grow 247.5% in 2025, thanks to new product launches from Meta and numerous other companies joining the race to put artificial intelligence on consumers' faces. This explosive growth reflects both improving technology and growing consumer awareness of smart glasses capabilities. Meta held a commanding position in the combined AR, VR, and displayless smart glasses market, with 60.6% share in Q2 2025. However, this dominance is not insurmountable, particularly as new entrants bring different strengths to the market. Samsung's manufacturing scale, Google's AI and software capabilities, and partnerships with established eyewear brands create a formidable combination. The smart glasses market is also seeing participation from Chinese manufacturers. Xiaomi captured 7.7% market share in Q2 2025, largely driven by newly launched AI glasses and older Mijia smart glasses, though these products were almost exclusively sold within China. Xreal held 4.1% share, Rayneo 2.7%, and Huawei 2.6%, demonstrating the fragmentation and opportunity in this emerging category. Amazon is reportedly developing consumer AR glasses codenamed Jayhawk, adding another major technology company to the competitive landscape. Apple is also widely expected to eventually release smart glasses, though the company has not publicly confirmed such plans. The entry of multiple well-funded companies with different strategic approaches suggests the smart glasses category will see rapid innovation and intense competition. Microsoft's Halo franchise, from Xbox icon to PlayStation arrival. Microsoft's recent announcement to bring the iconic Halo franchise to PlayStation represents a historic shift in gaming strategy and industry culture. Halo, long synonymous with the Xbox brand, will make its PlayStation debut with a full remake of its original title, Campaign Evolved, in 2026. This landmark decision signals Microsoft's move away from strict platform exclusivity, embracing multi-platform releases to reach wider audiences and adapt to an evolving entertainment landscape. This report comprehensively examines the history of Halo, the technical innovations behind Campaign Evolved, business drivers behind Microsoft's strategic change, industry and fan reactions, and the broader implications for game exclusivity and console identity in 2025 and beyond. Introduction. Since its inception, Halo has stood as the crown jewel of the Xbox platform, playing a defining role in both console success and the broader influence of shooter games in the industry. The decision to end its exclusivity marks a turning point, not only for Microsoft and Xbox, but for the entire culture of console gaming and digital entertainment. The legacy of Halo on Xbox. Halo's origins and evolution. Halo Combat Evolved, developed by Bungie, launched in 2001 as the flagship title for the original Xbox. Its release established Xbox as a legitimate contender in a market dominated by Sony and Nintendo, driving console sales and cementing Halo as a pop culture phenomenon. Subsequent sequels, spin-offs, and adaptations expanded Halo's universe, introducing millions of players worldwide to immersive storytelling, dynamic multiplayer, and an influential esports scene. Innovations and influence on gaming. Halo revolutionized console gaming with its dual analog stick control system, making first-person shooters accessible and precise for home players. It set new standards for online multiplayer, fostering player communities and competitive events long before esports became mainstream. The franchise's approach to AI, replay value, and weapon variety helped shape subsequent generations of shooters, including Call of Duty, Battlefield, and more. Halo's campaign, cooperative modes, and massive online battles were pivotal in making the Xbox Live service an industry standard. The franchise also drove sales and brand identity for Microsoft, spawning novels, comics, and multimedia adaptations, and generating over $6 billion in franchise sales by 2025. Halo's technical transformation, the campaign-evolved remake, visual and gameplay enhancements. The new Halo campaign-evolved remake brings the original's story and mechanics into the modern era with Unreal Engine 5, delivering 4K visuals, re-recorded voice acting, and stunningly realistic environments. The remake features 3 new prequel missions, 9 additional weapons borrowed from later franchise entries, hijackable vehicles, expanded arsenal, enhanced cinematics, and a redesign of the iconic Halo ringworld. Cross-platform features and accessibility. While the original Halo supported up to 2-player co-op, the remake expands this to 4-player online cooperative play and local split-screen, with full cross-play and cross-progression support for PlayStation, Xbox, and PC. New gameplay modifying skulls increase replay value, allowing players to customize enemy behavior, weapons, and environmental effects. The experience embraces modern gaming conventions while honoring the franchise's roots. The strategic shift. Why Microsoft ended Halo exclusivity, financial and market pressures. Microsoft's decision to break Halo's exclusivity is driven largely by financial imperatives. With Xbox hardware trailing in global sales, PS5 outsold Xbox Series consoles by more than 2-to-1 in 2025, and pressure from executives to improve profit margins. Microsoft is refocusing its strategy away from siloed hardware sales to maximizing franchise reach and recurring revenue. 60. The goal is greater operating leverage and to bring Xbox profitability more in line with other Microsoft business divisions. Xbox leadership perspectives. Xbox President Sarah Bond and gaming CEO Phil Spencer have publicly dismissed the idea of exclusive games as outdated, arguing that today's players expect top titles to be available across devices. 63. The leadership pivot aligns with a broader ecosystem mentality, competing not just with rival consoles, but with entertainment apps, streaming platforms, and online communities. The concept of platform identity is evolving, as confirmed by Xbox exec Matt Booty's statement that our biggest competition isn't another console, but TikTok and movies. Paragraph. Cross-platform success stories. Halo is not the first Microsoft franchise to cross the platform divide. Gears of War and Forza Horizon 5 both made successful debuts on PlayStation, bringing in new audiences and boosting revenues. Xbox's multi-platform games now regularly populate PlayStation sales charts, sustaining the brand even as hardware share declines. Industry reactions and cultural impact. PlayStation response. Sony's response to Microsoft's multi-platform strategy has been measured, viewing Microsoft's new approach as healthy and as a spur for further innovation. Sony continues to emphasize its own strengths in exclusive content, but PlayStation bosses have welcomed the additional competition. noting that diverse engagement models drive the industry forward and benefit consumers. Sorry. End of the episode. Fan reactions and community insights. The reaction among fans has been profoundly mixed. Xbox loyalists express frustration that exclusives like Halo are now available elsewhere, citing dwindling reasons to remain in the Xbox ecosystem, especially as Game Pass prices rise. Longtime PlayStation fans, meanwhile, celebrate the opportunity to experience Halo for the first time, while others question the necessity and impact of rebooting classic exclusives. Debates rage online about console wars, loyalty, and the future of hardware. Some fans feel a sense of nostalgia for exclusives, while others welcome the democratization of content. Future of exclusivity in gaming. Broader industry trends. 2025 marks an inflection point, with console exclusivity receding as studios and publishers prioritize reach, player engagement, and live service ecosystems over hardware wars. Cross-platform development is driven by powerful engines like Unreal and Unity, enabling smoother PC, console, and mobile compatibility. Subscription models, cloud gaming, and digital marketplaces are transforming how content is accessed, driving lasting changes in developer priorities and business models. Game Pass, cloud gaming, and subscription ecosystems. Microsoft has pivoted aggressively toward Game Pass, aiming for ubiquity across devices and platforms. Xbox now emphasizes accessibility and the power of its content library, encouraging developers to deliver games compatible with multiple screens and services. The future of Halo and many other franchises will be shaped by how publishers maximize engagement and recurring revenue beyond traditional console cycles. The rise of cloud gaming and mobile-first markets further blurs platform boundaries, making exclusivity less relevant to emerging generations of players. Conclusion. Microsoft's move to release Halo on PlayStation is not just a business exercise, but a cultural milestone for gaming. The Halo franchise, once synonymous with Xbox's identity, now stands as a symbol of the broader multi-platform future. A digital entertainment landscape where the most important games are enjoyed across devices, generations, and communities. As the console wars fade into memory, the value of exclusivity gives way to accessibility, reach, and shared experiences. Gamers, studios, and industry leaders alike must adapt to a reality where content is king, and platforms serve audiences wherever they may play. Anthropic's strategic cloud deal with Google, a comprehensive analysis of the 1 million TPU partnership. Executive Summary. In October 2025, Anthropic and Google announced a landmark cloud computing partnership that represents one of the most significant infrastructure deals in the artificial intelligence industry. This multi-billion-dollar agreement grants Anthropic access to up to 1 million of Google's custom-designed tensor processing units, TPUs, providing the AI startup with over 1 gigawatt of computing capacity expected to become operational by 2026. The deal, valued in the tens of billions of dollars, with industry estimates ranging from $50 billion to $100 billion, marks Anthropic's largest infrastructure commitment to date. This partnership significantly expands Anthropic's ability to train and deploy its Claude AI models while establishing Google Cloud as a major computing provider for the company. Notably, this development occurs while Amazon Web Services, AWS, maintains its position as Anthropic's primary cloud partner, having invested a total of $8 billion in the AI startup. This comprehensive analysis examines the strategic implications of this three-way relationship, the technological foundations underlying the partnership, and the broader ramifications for the rapidly evolving AI infrastructure landscape. The deal reflects the unprecedented demand for computing resources in the AI sector and highlights the complex multi-cloud strategies that leading AI companies are adopting to secure sufficient computational capacity for their ambitious growth trajectories. Chapter 1. The Genesis and Structure of the Google-Anthropic Partnership. Historical context and partnership evolution. The relationship between Anthropic and Google predates this landmark TPU deal. Google initially invested approximately $3 billion in Anthropic, establishing itself as a significant stakeholder in the AI startup's development. This financial backing positioned Google as both an investor and strategic technology partner well before the October 2025 announcement of the expanded cloud computing agreement. Anthropic began using Google Cloud's infrastructure and services in 2023 when the companies first signed a strategic partnership agreement. During this initial phase, Anthropic utilized Google Cloud's platforms, including Vertex AI and Google Cloud Marketplace, to offer its Claude models to enterprise customers. Major companies such as Figma, Palo Alto Networks, and Cursor leveraged these deployments, demonstrating the viability of the Google Cloud infrastructure for Anthropic's operations. The evolution from this initial partnership to the massive 1 million TPU commitment represents a strategic escalation driven by several factors. Anthropic's customer base has expanded to over 300,000 business customers, with the number of large accounts generating more than $100,000 in annual run rate revenue growing nearly sevenfold in the past year. This exponential growth created an urgent need for vastly expanded computing infrastructure to meet customer demand and support the development of increasingly sophisticated AI models. Deal structure and scope. The October 2025 agreement encompasses several key components that collectively position it as one of the most significant cloud infrastructure commitments in the AI industry. At its core, the deal grants Anthropic access to up to 1 million TPUs from Google's latest generations, including TPU v5e, economical variant, TPU v5p, performance variant, and the upcoming TPU v6. The deployment timeline follows a phased approach designed to match Anthropic's scaling needs. The first batch of 200,000 TPU v5p units was scheduled for delivery in the fourth quarter of 2025, with cumulative delivery reaching 500,000 units by the first half of 2026, including partial deployment of TPU v6 chips. The complete 1 million unit target is expected to be achieved by the second half of 2026, with full deployment of the more advanced TPU v6 architecture. This massive computational resource translates to over 1 gigawatt of AI computing capacity, a scale that industry observers have compared to the energy consumption of a medium-sized city. To contextualize this figure, industry experts estimate that building and operating a 1 gigawatt data center requires approximately $50 billion in investment, with roughly $35 billion typically allocated to chips and specialized hardware. Importantly, Anthropic receives dedicated TPU pools that are not shared with other Google Cloud customers. This exclusive access ensures that Anthropic's training tasks remain uninterrupted and provides priority access to the latest hardware as Google continues to develop and deploy new TPU generations. This arrangement differentiates the partnership from standard cloud service agreements and reflects the strategic importance both companies place on the relationship. Technical collaboration and integration. Beyond the raw computational resources, the partnership encompasses deep technical collaboration between Anthropic and Google engineering teams. This collaboration focuses on optimizing Claude model runtime efficiency on TPU architecture, including compiler optimization, memory management, and distributed training algorithm tuning. Anthropic gains direct access to Google's advanced software frameworks, including JAX, XLA, and TensorFlow, enjoying the same level of technical support as Google DeepMind, Google's internal AI research division. This privileged access to Google's AI software stack represents a significant advantage, as these frameworks have been developed and refined over years of internal use for Google's own cutting-edge AI research. Furthermore, Anthropic has been positioned as among the first external customers to access new TPU generations, including TPU v6, v7, and future processors. This early access arrangement provides Anthropic with opportunities to test and provide feedback on new hardware, helping Google improve its products, while ensuring that Anthropic can plan its infrastructure roadmap with visibility into upcoming technological capabilities. The cost structure of the deal, while not publicly disclosed in exact terms, appears to offer favorable economics for Anthropic. Google Cloud CEO Thomas Kurian emphasized that Anthropic's decision reflects the strong price performance and efficiency its teams have seen with TPUs for several years. Anthropic specifically selected TPUs based on their advantageous cost-effectiveness and efficiency, alongside the startup's established experience in training and deploying Claude models using these processors. Chapter 2. Understanding Tensor Processing Units, TPUs. TPU architecture and design philosophy. Tensor Processing Units represent Google's custom-designed application-specific integrated circuits, ASICs, specifically optimized for neural network machine learning workloads. Unlike general-purpose processors, TPUs are engineered to excel at the specific mathematical operations that dominate AI model training and inference, particularly matrix multiplication and tensor processing operations. The fundamental architectural innovation underlying TPUs is the systolic array design. This architecture consists of thousands of multiply accumulator units directly connected to each other, forming a large physical matrix. In this design, data flows through the array in a wave-like pattern, with each processing element performing calculations and passing results to neighboring elements. This approach minimizes memory access requirements during computation, as intermediate results move directly between processing elements rather than being stored and retrieved from memory. Cloud TPU v3, for example, contains two systolic arrays of 128 times 128 arithmetic logic units, ALUs, on a single processor. This massive parallelism enables TPUs to achieve exceptional throughput for the matrix operations that constitute the bulk of neural network computations. The TPU architecture handles multiply-accumulate operations, the fundamental building blocks of neural network calculations, with remarkable efficiency by eliminating the need for memory access during the matrix multiplication process itself. Google designed TPUs to handle high volumes of low-precision computation, often operating with as little as 8-bit precision. This design choice reflects the observation that many neural network operations do not require the high precision offered by traditional floating-point arithmetic. By optimizing for lower precision operations, TPUs can pack more computational units into the same chip area and power budget, dramatically increasing throughput for AI workloads. TPU evolution and performance characteristics. The development of TPU technology represents a remarkable achievement in rapid hardware design and deployment. Google began considering building an ASIC for neural networks as early as 2006, but the project became urgent in 2013 when the company realized that the fast-growing computational demands of neural networks could require doubling the number of data centers it operated. The first-generation TPU was designed, verified, built, and deployed to Google's data centers in just 15 months, an extraordinarily fast timeline for processor development. This initial TPU was built on a 28-nanometer process, ran at 700 MHz, and consumed 40 watts when running. To accelerate deployment, Google packaged the processor as an external accelerator card that fit into a SATA hard disk slot, enabling drop-in installation into existing servers. Performance analysis of the first-generation TPU revealed remarkable achievements. Google found that the TPU delivered 15 to 30 times higher performance than contemporary CPUs and GPUs, along with 30 to 80 times higher performance per watt. These advantages enabled many of Google's services to run state-of-the-art neural networks at scale and at affordable cost. Subsequent TPU generations have built upon this foundation with continuous improvements in performance, efficiency, and capabilities. The TPU v5 family introduced specialized variants optimized for different use cases. TPU v5e focuses on economical performance for cost-sensitive workloads, while TPU v5p emphasizes maximum performance for demanding training tasks. Each TPU v5p chip provides approximately 459 teraflops of BF16 brain floating point computing power. The upcoming TPU v6, codenamed Ironwood, represents Google's first TPU specifically designed for the age of inference. This seventh-generation TPU is optimized for running thinking, inferential AI models at scale and features breakthrough inter-chip interconnect (ICI) networking. TPU v6 systems can scale up to 9,216 liquid-cooled chips, spanning nearly 10 megawatts of power. TPU advantages for AI workloads. TPUs offer several compelling advantages for AI model training and deployment compared to general-purpose GPUs. The specialized architecture delivers superior performance and efficiency for the specific mathematical operations that dominate neural network computations, particularly the matrix multiplications and tensor operations that occur billions of times during model training. Energy efficiency represents a critical advantage of TPU architecture. Google reports a 67% increase in energy efficiency in TPU v6e compared to v5e. This improvement reflects the ongoing optimization of TPU design so AI workloads and the benefits of custom silicon tailored to specific computational patterns. In an era where data center energy consumption has emerged as a major concern, these efficiency gains translate directly to reduced operational costs and environmental impact. The TPU architecture's focus on high-volume, low-precision operations aligns particularly well with modern AI training techniques. Research has demonstrated that many neural network operations can be performed with reduced numerical precision without significant degradation in model quality. By optimizing for these reduced precision workloads, TPUs can achieve higher throughput and lower energy consumption compared to processors designed for general-purpose computing. Another significant advantage stems from the tight integration between TPU hardware and Google's software stack. The JAX, XLA, and TensorFlow frameworks have been developed in tandem with TPU hardware, ensuring optimal performance and efficiency. This co-design approach enables Google to extract maximum computational efficiency from the hardware through software optimizations that would be difficult or impossible to achieve with third-party processors. For Anthropic specifically, TPUs offer a proven track record of supporting advanced AI model development. Google has used TPUs internally for a wide range of applications, from powering Google Search and Google Photos to enabling DeepMind's AlphaGo Zero project, which defeated World Go champion Lee Sedol using just a single machine in the Google Cloud with 4 TPUs. Chapter 3: Anthropic's Multi-Cloud Strategy and AWS Partnership. The Amazon Web Services Relationship. While the Google TPU deal has garnered significant attention, Amazon Web Services remains Anthropic's primary cloud provider and largest investor. Amazon's relationship with Anthropic began in September 2023 with an initial investment of $1.25 billion, expandable to $4 billion. This initial partnership established AWS as Anthropic's primary cloud provider for mission-critical workloads, including safety research and future foundation model development. In November 2024, Amazon invested an additional $4 billion in Anthropic, doubling its total investment to $8 billion while maintaining its position as a minority investor. This expanded collaboration deepened the technical partnership, with Anthropic committing to use AWS Trainium and Inferentia chips to build, train, and deploy future foundation models. The agreement positioned AWS as Anthropic's primary cloud and training partner. The AWS partnership encompasses several key components beyond financial investment. Anthropic committed to run the majority of its workloads on AWS, providing the company with access to advanced cloud technology. Through Amazon Bedrock, AWS's fully managed service for accessing foundation models, Claude has become core infrastructure for tens of thousands of companies. Major enterprises leverage Claude through Amazon Bedrock for critical applications. Pfizer uses Claude models to accelerate research and delivery timelines for medicines, while saving tens of millions in operational costs. Intuit employs Claude to explain complex tax calculations for millions of users during tax season. The European Parliament leverages Claude to power Archibot, making 2.1 million official documents instantly searchable and easier to analyze in multiple languages, while reducing research time by 80%. Technical collaboration on AWS Trainium. A critical component of the Amazon partnership involves Anthropic's work with AWS's custom AI chips, particularly the Trainium family of processors. Anthropic is collaborating closely with Annapurna Labs at AWS on the development and optimization of future generations of Trainium accelerators. This collaboration involves deep technical engagement, with Anthropic engineers writing low-level kernels that allow direct interface with Trainium silicon and contributing to the AWS Neuron software stack. Anthropic's engineers work closely with Annapurna's chip design team to extract maximum computational efficiency from the hardware, which the company plans to leverage for training its most advanced foundation models. AWS Trainium 2, the latest iteration, offers compelling performance characteristics. According to AWS and industry analysis, Trainium 2 chips provide 30 to 40% better price performance compared to GPU-based instances. This cost advantage positions AWS as a formidable competitor in the AI training market and provides Anthropic with an economically attractive option for certain workloads. However, the Trainium partnership has faced some challenges. According to industry reports, some Anthropic engineers initially expressed preferences for NVIDIA's CUDA stack due to its maturity and comprehensive tooling ecosystem. The Anthropic teams had to adapt their CUDA-based pipelines for Trainium, resulting in some delays and performance challenges during the transition period. While Amazon highlighted the partnership as a significant achievement, it required compromise and adaptation from both parties. Strategic rationale for multi-cloud deployment. Anthropic's decision to maintain significant partnerships with both AWS and Google Cloud, while also distributing models through Microsoft Azure, reflects a deliberate multi-cloud strategy driven by several strategic imperatives. This approach diverges from the simpler single cloud model, but offers substantial advantages for a company with Anthropic's scale and ambitions. Risk mitigation represents a primary driver of multi-cloud adoption. By distributing workloads across multiple cloud providers, Anthropic reduces its dependency on any single vendor and gains protection against service disruptions, pricing changes, or other challenges that might affect a single provider. For a company whose business depends entirely on reliable access to massive computational resources, this redundancy provides essential business continuity assurance. Each major cloud provider brings distinct strengths to the table. Google Cloud excels in AI and analytics capabilities, offering cutting-edge TPUs and advanced AI frameworks developed through years of internal research. AWS provides unmatched elasticity and global scale, with the broadest range of services and the most extensive global infrastructure. Microsoft Azure offers superior enterprise integration and hybrid cloud capabilities, particularly valuable for companies operating in regulated industries. By leveraging multiple providers, Anthropic can strategically place workloads where they will perform optimally and most cost-effectively. Training workloads might run on Google TPUs when cost performance favors that platform, while inference workloads might run on AWS Trainium or through Azure for enterprise customers already embedded in the Microsoft ecosystem. This optimization across providers can yield significant cost savings and performance improvements compared to a single cloud approach. The multi-cloud strategy also provides negotiating leverage. By maintaining significant relationships with multiple providers, Anthropic can negotiate more favorable terms and avoid vendor lock-in that might limit its flexibility or expose it to unfavorable pricing changes. This dynamic is particularly important given the massive scale of Anthropic's computational needs and the rapid evolution of cloud pricing models. Chapter 4. The competitive landscape and industry context. The AI compute arms race. The Anthropic-Google TPU deal must be understood within the broader context of an unprecedented AI compute arms race sweeping through the technology industry. Leading AI companies are securing massive computational resources at a scale that would have been unimaginable just a few years ago, driven by the recognition that access to sufficient computing power has become the primary constraint on AI development. OpenAI, Anthropic's primary competitor, has entered into several agreements that could exceed $1 trillion to secure approximately 26 gigawatts of computing capacity, sufficient energy to power nearly 20 million American homes. This staggering commitment dwarfs even Anthropic's massive Google Cloud deal and underscores the scale of infrastructure investment that leading AI companies consider necessary for their future development. The broader hyperscaler investment trend is equally remarkable. Microsoft, Google, Amazon, and Meta forecast a combined $364 billion in capital investment for 2025, with the vast majority directed toward data center infrastructure to support AI workloads. These four companies alone spent more than $100 billion on data center projects in just the 3 months leading up to August 2025. Industry analysts at McKinsey project that data centers equipped to handle AI processing loads will require $5.2 trillion in capital expenditures between 2025 and 2030, under their base scenario, with an accelerated demand scenario potentially requiring $7.9 trillion. This massive investment reflects the construction of approximately 125 gigawatts of additional AI-related data center capacity during this period. The race for custom AI chips. While NVIDIA has dominated the AI chip market with its GPU offerings, major cloud providers are aggressively developing custom silicon to serve AI workloads. This trend toward custom chips represents both a competitive response to NVIDIA and a strategic effort to optimize cost, performance, and availability for AI-specific computations. Google's TPU program exemplifies this custom chip strategy. The TPUs offer superior performance and efficiency for many AI workloads compared to general-purpose GPUs, and Google retains full control over the development roadmap and production capacity. According to SemiAnalysis founder Dylan Patel, Google's TPUs and Amazon's Trainium processors are gaining significant traction due to their performance and efficiency advantages. Amazon's development of Trainium represents a parallel effort to reduce dependency on NVIDIA while strengthening its AWS ecosystem. AWS customers often face long wait times for GPU-powered instances, and Amazon hopes to address this challenge by offering Trainium as a scalable and cost-effective alternative. The Trainium 2 iteration is positioned as a direct competitor to NVIDIA's offerings, with innovations in processing power, cost efficiency, and energy savings. Microsoft has also invested in custom AI chips, though details of its efforts are less publicly documented than Google's and Amazon's programs. The proliferation of custom chip development by hyperscalers creates a more diverse and competitive landscape for AI compute, potentially challenging NVIDIA's dominant market position. However, NVIDIA maintains significant advantages that make displacing it challenging. The company's CUDA software ecosystem represents years of development and optimization, with extensive libraries, tools, and documentation that developers have come to rely upon. Many AI researchers and engineers prefer NVIDIA GPUs precisely because of this mature software stack, which can accelerate development and reduce technical challenges compared to newer custom chip offerings. Enterprise AI adoption patterns. The demand driving these massive infrastructure investments stems from rapidly accelerating Enterprise adoption of AI technologies. Anthropic's business model, focused heavily on enterprise customers, positions the company to capitalize on this trend. Approximately 80% of Anthropic's revenue comes from enterprise clients, reflecting the company's strategic focus on business applications rather than consumer products. Analysis of API usage patterns reveals that businesses use Claude differently than individual consumers, with a clear emphasis on automation and task delegation. More than 77% of corporate usage through Anthropic's API involves automation patterns, often representing full task delegation to AI systems. This contrasts sharply with consumer usage of chatbots like ChatGPT, where personal assistants and creative tasks dominate. The most common enterprise use cases for Claude center on coding and administrative tasks, which together account for approximately 39% of business usage. This concentration in well-defined, high-value tasks reflects the pattern that enterprise AI adoption tends to focus on areas where deployment is straightforward, capabilities are robust, and economic benefits are clear. Anthropic has emerged as the leading provider of AI models for enterprise coding applications, capturing 42% of enterprise usage in this category, more than double OpenAI's share. This dominance in coding has become a crucial differentiator and revenue driver for Anthropic, particularly following the launch of Claude 3.5 Sonnet and subsequent models that demonstrated exceptional performance on programming tasks. The total enterprise large language model market has shifted dramatically in Anthropic's favor. Menlo Ventures reported that Anthropic now holds 32% of the enterprise LLM market by usage, compared with OpenAI's 25%, a remarkable change from 2023, when OpenAI held half the market and Anthropic only 12%. Chapter 5. Anthropic's Business Model and Growth Trajectory. Revenue Growth and Projections. Anthropic has experienced explosive revenue growth that ranks among the fastest in technology industry history. The company's trajectory demonstrates the enormous commercial potential of frontier AI models and the rapidly expanding market for enterprise AI solutions. At the beginning of 2025, less than 2 years after Claude's launch in March 2023, Anthropic's annualized run rate revenue had reached approximately $1 billion. By August 2025, just 8 months later, the company's run rate revenue exceeded $5 billion, a 5-fold increase in under a year. This growth rate positions Anthropic among the fastest-growing technology companies ever measured. The company's internal projections suggest this growth will continue at an extraordinary pace. Anthropic expects to reach $9 billion in annualized revenue by the end of 2025. Looking ahead to 2026, the company has set ambitious targets ranging from $20 billion to $26 billion in annualized revenue, representing potential growth of 122% to 189% compared to the 2025 target. These projections have drawn both enthusiasm and skepticism from industry analysts. The use of annualized run rate revenue, which extrapolates a single month's revenue to project annual performance, introduces significant uncertainty into these figures. Monthly revenue can fluctuate due to seasonal patterns, one-time deals, or temporary surges in usage, making annualized figures potentially unreliable as long-term predictions. Nevertheless, multiple factors support the plausibility of continued strong growth. Anthropic's customer base has expanded to over 300,000 business customers. More significantly, The number of large accounts representing over $100,000 in annual run rate revenue has grown nearly sevenfold in the past year. This expansion of high-value enterprise customers provides a more stable and predictable revenue foundation than consumer subscriptions. Revenue composition and business model. Anthropic's revenue derives from several distinct channels, with enterprise and startup API access representing the dominant source. Analysis suggests that API calls from businesses and startups drive approximately 70 to 75% of total revenue through pay-per-token pricing models. Claude Sonnet maintains pricing of $3 per million input tokens and $15 per million output tokens for its latest versions. The company distributes its models primarily through major cloud platforms, particularly AWS Bedrock and Google Vertex AI. This distribution strategy leverages the existing relationships and trust that enterprises have with major cloud providers, reducing friction in the sales process and enabling rapid scaling to large customer bases. Consumer subscriptions, including Claude Pro at $20 per month and Claude Team at $30 per month, account for approximately 10 to 15% of revenue. While smaller than the enterprise segment, these consumer offerings provide important benefits, including direct user feedback, broader brand awareness, and a pipeline of potential enterprise customers who may upgrade their organizations to business plans. A standout revenue driver has emerged in the form of Claude Code, launched as a standalone product in February 2025. This specialized coding assistant grew from an estimated $17.5 million in annualized revenue in April 2025 to $400 million by the end of July 2025, and subsequently reached over $500 million in run rate revenue, with usage growing more than tenfold in just 3 months. This explosive growth in coding applications underscores Anthropic's strength in this critical enterprise use case. The concentration of revenue in coding and automation use cases creates both opportunities and risks. On one hand, these applications demonstrate clear value propositions with measurable productivity improvements and cost savings, making enterprise sales easier and retention stronger. On the other hand, dependence on a relatively narrow set of use cases could create vulnerability. If competitors achieve comparable or superior performance in these specific areas, funding and valuation, Anthropic has raised extraordinary amounts of capital to fuel its development and infrastructure investments. The company has secured approximately $23.15 billion in total funding as of 2025. This capital has come from a combination of strategic investments from cloud providers, venture capital firms, and other technology companies. The most recent funding round in September 2025 raised $13 billion at a post-money valuation of $183 billion. This valuation represents a nearly threefold increase from the company's $61.5 billion valuation earlier in 2025. This growth and investor enthusiasm about the AI market's potential. The $183 billion valuation places Anthropic among the most valuable private technology companies in history. However, this valuation also highlights a significant gap between market value and current revenues, a common pattern in the AI industry, but one that raises questions about long-term sustainability and profitability. Like OpenAI and other leading AI companies, Anthropic is not currently profitable despite its substantial revenues. The company's Costs include enormous infrastructure expenses, both capital expenditures for hardware and operational expenses for cloud services, significant research and development investments, and growing teams of highly compensated AI researchers and engineers. The path to profitability remains unclear, with the company apparently prioritizing growth, market share, and technological leadership over near-term financial returns. Chapter 6: The Energy and Environmental Implications. Data center power consumption. The Anthropic Google deal's 1 gigawatt computing capacity represents an enormous energy commitment that exemplifies the broader environmental challenges facing the AI industry. Understanding the scale of this energy consumption and its implications is essential for evaluating the sustainability of current AI development trajectories. A 1 gigawatt power requirement equals 1,000 megawatts, sufficient to power a medium-sized city. To contextualize this figure, the International Energy Agency projects that global data center electricity consumption will more than double from 415 terawatt-hours in 2024 to 945 terawatt-hours in 2030, roughly equivalent to Japan's current annual electricity consumption. U.S. data centers specifically consumed 183 terawatt-hours of electricity in 2024, accounting for more than 4% of the country's total electricity consumption. This figure is projected to grow by 133% to 426 terawatt-hours by 2030. The surge in demand has created significant strain on regional power grids, particularly in areas with concentrations of data centers. Virginia, which hosts a large concentration of data centers, saw these facilities consume approximately 26% of the state's total electricity supply in 2023. Other states with significant data center presence, including North Dakota, 15%, Nebraska, 12%, Iowa, 11%, and Oregon, 11%, also experienced notable impacts on their power grids. AI-specific energy challenges. AI workloads represent an especially energy-intensive category of data center operations. Analysis by Alex DeVries, creator of the Digiconomist Tech Sustainability Platform, suggests that AI technologies may represent nearly half of data center energy consumption by the end of 2025, potentially reaching 49% of total data center energy use, excluding cryptocurrency mining. The energy intensity of AI stems from the computational demands of training and running large language models. Training a single large AI model can consume as much energy as 120 U.S. homes use in an entire year. High-performance computing clusters used for AI applications require significantly more power than traditional data center infrastructure, with average power density per rack expected to rise from 20 kilowatts to 50 kilowatts by 2027. The challenge extends beyond raw power generation to include cooling requirements. AI workloads generate tremendous heat due to the high power density of GPU and TPU clusters. Traditional air cooling systems are becoming obsolete for cutting-edge AI infrastructure, with liquid cooling emerging as a necessity cooling for AI hardware. Liquid cooling is approximately 3,000 times more efficient than air, but implementing these systems requires substantial additional investment and infrastructure modifications. Approximately 73% of new AI facilities are deploying direct-to-chip or immersion cooling systems to manage these thermal challenges. While more efficient than air cooling, these advanced cooling systems still consume significant energy and require careful water management, creating additional resource consumption concerns. 6.3. Sustainability responses and challenges. The environmental impact of AI infrastructure has prompted various responses from technology companies and policymakers. Google has committed to powering its data centers with 100% renewable energy, and the facilities supporting Anthropic's TPU deployment will benefit from these renewable energy initiatives. Microsoft, Amazon, and other major cloud providers have made similar commitments to carbon neutrality and renewable energy adoption. However, the sheer scale and rapid growth of AI energy demands pose significant challenges to these sustainability goals. Goldman Sachs research forecasts that approximately 60% of increasing electricity demands from data centers will be met by burning fossil fuels, potentially increasing global carbon emissions by around 220 million tons. This projection suggests that renewable energy development may not keep pace with the explosive growth in AI infrastructure demands. The geographic concentration of data centers creates additional challenges. Regions with existing data center clusters face mounting pressure on local power grids and water supplies. The need for low-latency connections and proximity to network infrastructure hubs concentrates data centers in specific geographic areas, exacerbating regional resource constraints. Energy efficiency improvements in AI chips and algorithms offer partial solutions. Google reports significant efficiency gains in successive TPU generations, including a 67% increase in energy efficiency in TPU v6e compared to v5e. Similarly, advances in model architecture and training techniques can reduce the computational requirements for achieving given levels of AI capability, potentially slowing the growth in energy consumption even as AI capabilities advance. Nevertheless, the overall trajectory remains concerning. Despite improvements in efficiency, total energy consumption continues to rise due to the substantial increase in AI usage and the deployment of ever larger models. Researchers and policymakers increasingly recognize that technological efficiency gains alone may be insufficient to address the environmental impact of AI development, potentially requiring policy interventions or industry standards to promote sustainable practices.